Okay, so let's have a look at the Junior Certificate Higher Level Maths Paper 1 for 2018 and look at question 6. So a sheet is folded in half a number of times. H of x is a function and it's 2 to the power of x, and it's the number, it gives us the number of layers after x folds. Fill in the table to show the number of layers after each of the first 6 folds. So you can see here that the top row here gives us the number of folds, the x's in other words, and the number of layers then is given by this row here. So in other words, 2 to the power of 1 here will give us 2. 2 to the power of 2 will give us 4. 2 to the power of 3 will give us 8. So 2 to the power of 4 here, you can do it on your calculator, but it's just 16. 2 to the power of 5 will give us 32, and 2 to the power of 6 will give us 64. You can see actually what's happening here is that every time you fold the sheet, the number of layers actually doubles. So it goes from 2 to 4 to 8 to 16, 32 and 64. Okay, so that's part A. Now in part B here it says list the elements of the domain and the range of h of x. Well, the domain contains all the inputs, so our domain is just going to be 1, 2, 3, 4, 5 and 6. Now the range that will give us the actual outputs. So the actual outputs then are 2, 4, 8, 16, 32 and 64 for this particular table here. Okay, so that's it. Work out the least number of folds that would be needed to have more than 500 layers. So the number of layers is given by 2 to the power of x. So the number of layers is going to be 2 to the power of x. So we know that if we look at our table here, if we take 2 to the power of 6 will give us 64. So 2 to the power of 6 will give us 64 layers. So if we fold the page or the sheet 6 times, we'll end up with 64 layers. 2 to the power of 7 then, if we fold the sheets again, we'll get 128. Double this. If we fold again, so we have 2 to the power of 8, so we fold 8 times, we'll get double this again, so that's 256. And again, if we fold again 9 times, this time we'll get 512. So we need to fold, if we fold the sheet 8 times, we get 256 layers. If we fold the sheet 9 times, we do get more than 500 layers. So the least number of folds that would be needed to have more than 500 layers then would be 9. The least number of folds would be 9 to give us more than 500 layers. Okay, so part D here just asks us to work out the number of layers after 12 folds. Well, that's just 2 to the power of 12. And 2 to the power of 12, again, you can do that on your calculator. It's 404096. Now, it also says give your answer in the form a by 10 to the power of n, where a is an element of OR. A is between 1 and less than 10, between 1 and 10, including 1, not including 10, and n is a natural number. In other words, put this number here in scientific notation. So what you do here is you take the decimal point, which is here, and we're just going to bring it back here to make a number between 1 and 10, including 1, not including 10. So 4.096 is our A. Now this is not 4096, so we've got to move that decimal point back again by multiplying it by 10 to the power of something. So how many places would we need to move this decimal point to bring it back to here again? Well, it would be 1, 2, 3, and it's to the right, so it's plus 3. So this is our answer here, 4.096 by 10 to the power of 3. That's it for that part. So let's have a look at E. Explain what the following statement means in terms of folds and layers. So we have H14 is greater than 10,000. Now the 14 here is our X. So X is the number of times we fold the sheet. So what this says is 14 folds of the sheet will result in more than 10,000 layers. So if we fold the sheet 14 times, we'll end up with more than 10,000 layers. So 2 to the power of 14 is actually, so if you work it out on your calculator, 2 to the power of 14 is actually 16,384. 16,384. So that's well over 10,000. Okay, so let's have a look at part F. Put a tick in the correct box to show what kind of pattern is made by the number of layers. So the number of layers is given by 2, 4, 8, 16, 32 and so on. What's actually happening here is we're doubling each number to get the next number. So that means it's exponential. So we're going to put a little tick here to say that it's exponential. And why? Well, we would say something like, let's see, we are multiplying each number, or number of layers if you like, by 2 to get the next number, or number of layers. There are any number of ways you can say this, but that's one possible way you could say it. Okay, next one. After a certain number of folds, there are k layers. How many layers will there be after 3 more folds? So we know that we're doubling. It's going from 2 to 4 to 8 to 16 to 32 and so on. So we're doubling each time. So if there are k layers after a certain number of folds, well, if we fold it again, there will be double that, so there will be 2k layers. So that's after 1 more fold. After 2 more folds, there will be double this, so there will be 4k layers. And if we double this again, we'll get 8k layers. So the answer here is, so they're asking us, they're saying after a certain number of folds there are k layers. How many layers will there be? So the answer is 8k layers. So if we started with k layers, we double each time. So if we fold it once, twice, 3 times, we'll end up with 8k layers. Okay, so next question then is part H, and it says, let's see, after a certain number of folds there are 2 to the power of p layers. How many layers will there be after 3 more folds? Well, this is the same thing again. If there are this many layers and we fold again, there will be twice 2p layers the next time we fold. If we are to fold again a second time, there will be twice this, so it will be twice times 2 times 2p if you like. So that's just equal to 4 times 2 to the power of p. And if we fold again, we'll get 2, double this again, we got to double this, or just 8 times 2 to the power of p layers. So this is our answer here. However, it says give your answer in the form 2 to the power of m. So we have 8 times 2 to the power of p. We got to change that to 2 to the power of something only. So change the 8 to 2 to the power of something, that's 2 cubed. Here we've got a 2 to the power of p. So we've got 2 cubed, 2 times 2 times 2 will give us 8. And here we've got, sorry that's wrong here, I'll just change that. This is 2 to the power of p here. So we have 2 cubed times 2 to the power of p. Well, you just add the powers here. So it's 2 to the power of 3 plus p. Or 2 to the power of p plus 3, whichever way you want to write it. So now we have it in the form 2 to the power of m, where m is in terms of p. So this is our m here, and it is in terms of p. So this is our answer here, if you like. Yeah. Okay. So that's H. I think that's it. Yep. That seems to be it for this particular question.